Hello teacher, today I'm going to present my final project, Advanced Probability and Statistics. So let's start. First of all, what is our final project about is taking the real world data set and analyzing it by Python or R. So first of all, here is our dataset is from the Kaggle dataset, and it's the real world dataset. I have taken the ones recommended and recommended by you, and the data includes around 2938 rows and 24 columns. The data set is from 183 countries, which is the mean of information from each country from 2000 to 2015 about genders, mortality, some disease, and so on. So first of all, the data set has been cleaned, and then we did a summary of it by R. We have looked through some means, modes, and medians of it through the characteristics by the R studio. So and then we had to make some hypotheses and analyze this hypothesis according to the data set. So here's the first hypothesis we have taken. Our null hypothesis is there is no significant difference in life expectancy between men and women. And alternative hypothesis is of course the opposite one. Like as we know, in the real world, like it is tend to say that women live more than men in most of the countries. Like in general, men live less than women. But according to our data, we wanted to see if it is like true for our data set and if it is statistically significant. So in order to analyze it, we use the t-test by R-code, and our p-value, it came out to be 0.95. So it is way more greater than 0.05. That's why we failed to reject the null hypothesis. And when we fail, we cannot say that there is a significant difference, like one man is more than woman or woman is more than man. So we just say there is no significant difference. And then the second hypothesis is about there is no significant association between a country's GDP and life expectancy for both women and men. And here we have taken separately, like not together but separately. For men we analyze it separately, for women we analyze it separately. And the alternative hypothesis is the same, the opposite. So here for the woman we analyzed GPT and women's. Here the correlation coefficient came out to be 0.01 and p-value 0.51. From p-value we can see that this is very big, bigger than 0.05, so we failed to reject the first part of the null hypothesis for women. Of course, for men we will see later. Here we have used it to mention Pearson correlation coefficient, and here the coefficient for the man is 0.05, but p-value is 0.01, which is less than 0.05. Here we can accept the alternative hypothesis for the men. So in this hypothesis, for women we fail to reject the null hypothesis. For men we accept the alternative hypothesis. And here the third hypothesis is about there is no significant correlation between the life expectancy of men and women in developed countries and developing countries. So alternative is the opposite one. So here why we took this hypothesis, like we wanted to know in developed countries and developing countries, between both men and women, is there any difference? For example, if the country is developed, is it more likely that the people will live longer or not. And for this hypothesis, we are also using the Pearson correlation coefficient, and our p-values for women is 0.61. We checked analyzed it by developing and developed countries. So as we can see, the p-value is very big. That's why we failed to reject the null hypothesis. As we failed to reject the null hypothesis, we can not say that there's a significant correlation. So for men it's the same, the p-value is 0.51, where we also failed to reject the null hypothesis. So as we have seen from here, for both men and women we didn't find any statistical significant result to say that there is a significant correlation between the life expectancy of men and women in developed and developing countries. So the fourth hypothesis is there is no significant association between the percentage of immunized individuals, polio, diphtheria, and infant mortality rates. So here we want to say if there is like any association between immunization and infant mortality in countries. Here we use as a linear regression model. So first of all, we check separately. Polio is separate with infant mortality, diphtheria is separate. So here coefficient for polio is 0.5 and p-value for polio is 0.016, which it says us that there is a negative correlation. The p-value as it is little, we can accept the alternative hypothesis and we can say that polio has a significant association with infant mortality, and the diphtheria one is also, the p-value is very little. Here we can also accept the alternative hypothesis. So in the end, what we can say is that the polio and diphtheria, they for sure have an association with infant mortality. So this was the end of our hypothesis analysis. We found interesting results, so let's go to the next step. It is regression analysis. For the part of, actually we have already done the regression analysis like in our fourth hypothesis, but we wanted to make it like more one more regression analysis separately. Here we have chosen independent and dependent variables. Dependent ones are life expectancy men and life expectancy women. Independent ones are polio and diphtheria. In previous hypothesis we had the polio, diphtheria, and infant mortality. Here we have polio, diphtheria, and life expectancy of adults. So the regression analysis, first of all, it is life expectancy of men and polio, and another part is with diphtheria. So here, as you can see, for the polio, coefficient is 0.0303, and here p-value is 0.7, which tells us we failed to we cannot say there is no relationship between polio and life expectancy, and diphtheria is the same. P-value is very big. That's why we don't have any evidence to say that polio and diphtheria, they do affect the life expectancy. And the life expectancy of women and polio, diphtheria, it is the same. You can see the p-values, T09 and 0.6. Here we also don't have any evidence for the saying that polio, diphtheria has any impact on life expectancy of women and men. So from a linear regression, we see that independent variables, they are not affecting the dependence in any way. So the next step is a simple sampling random sampling model. So here we had to sample from the initial population, from original population, and other samples, to see if the characteristics of the population change or not, if there are a big difference between original population with the new sample or not, to see the reliability. All the data are in ARCOD, but here we just put two box plots to visualize. The box plots here, as you can see, in the left hand, it is for the life expectancy of man. As you can see, the shapes are almost the same, identical. In the right hand, it's also almost the same, it doesn't have a big difference. That's why we had more box plots, but we didn't want to include all of them here. And the second method is bootstrapping method. The bootstrapping method is almost the same, the results didn't differ very much from the previous one, original data set, simple random sampling, and bootstrapping method. They almost had the same results, of characteristics. When we look through the means, modes, even if there were a difference, it was kind of not very big difference, maybe around 1%, 2%, which is we don't think that it is a big difference between characteristics. So here, as you can see, the box plus of bootstrapping and the simple random sampling, they are almost the same. We took it for the same variables, and they are compared with the original dataset of our, which we took from Kaggle. So like this. And then the confidence intervals, we did some we calculated some confidence intervals with again ARCOD to see if what confidence interval tells us. For example, for me this the confidence interval of 0.05, it tells us all the central tendencies, mean, mode, median, all of them lie between these two values. So here we calculated the confidence interval for 5 variables which we're interested in. So as a conclusion, we have done all this analysis for our data, and we got some interesting results, immunization impacts infant mortality but not adult life expectancy. Gender-based life expectancy differences contradicted common assumptions. GDP positively correlates with life expectancy for men but not women. No significant correlation between country development status and life expectancy. We also have done some linear regression analysis, confidence intervals, bootstrapping sampling, simple random sampling, and so on. Also, as we have done all of this analysis, we also have some limitations. For the further research, there might be done more analysis to this data, because this data was really a huge one. In the future, we can get even better, more interesting results by analyzing other variables and so on. So this is the end of my presentation. Thank you for attention, teacher. Thank you for the lessons during all the semester. See you.